G'day guys, Alan here. Welcome to my workshop. Flushed with success from building the Webster engine, I'm going to embark on building another engine. This one's the Lynx15. It's a single overhead cam design, so a little bit more sophisticated I guess than the Webster. It's based on an original design by Malcolm Stride. It was published some years ago in one of the model engineering magazines. But it's been redrawn more recently by Greg of Greg's Machine Shop. I've got a link to his site below. The key characteristics: it's made from bar stock, doesn't have any castings. The crankcase is enclosed, so the Webster has the attraction of a external or exposed crankshaft and so on, but it's quite messy in operation, whereas this one's fully enclosed. And also it's an overhead cam design with a belt-driven single overhead cam, so that'll be interesting. I'll have a picture included in this frame somewhere, which shows an example of the original Malcolm Stride design engine, which was made by a chap called Kevin Woods. I've got a link to his site in the link below as well. And I bought a set of drawings from Greg's Machine Shop, and I have the drawings for the cylinder and the crankcase, so I can get started with that. And the scrap box yielded some material appropriate for the crankcase and the nose on the front. So we can dive in and start making some chips. So let's get to it. I'm going to start by making the nose piece, and the outside dimensions of that, the maximum outside dimensions are 62 diameter and 60 millimeters long. Well, I don't have a piece of material which is big enough to do that, but the scrap bin does have these two pieces. This bit's 63.5 and this bit's long enough to make up the rest of it, so I'm going to join these two together. And the way I'll do that is with a 40mm counter bore in here, 12 deep, and a matching nose on the front of that piece, and I'll join them together with Loctite retaining compound. Alright, we're down to 39.98 now. There we go. You saw how tight that was. But it does move, so I think with the lubrication of the Loctite, that might be just about perfect. I'm going to call it quits there. Okay, time to stick these two together. Now you saw that they actually go together without any force, but I'm going to do it with the press, mostly because it will make it easy to press them with correct alignment. Here we go then. So, for better or for worse, that's squidged on. Oh, it's squeezed out nicely all the way around. So let's clean all that off, I guess. Okay, well I've now got a piece of aluminium that's long enough and has the major diameter I need, and hopefully it will behave as a single piece. I guess time will tell. But I've used that retaining compound a little bit as dynamite. Stick things together with that, they tend to stay stuck. But it's not the end of the world if there's a problem. But yeah, it's allowed me to use 2 bits of scrap instead of having to go out and buy a piece. I don't know how much you'd pay for a piece like that, probably about $30 Australian or something, I don't know. Anyway, we press on. Okay, so we've got our piece back in the lathe now, and it needs to have an 18mm hole right through the middle. So I'll start off with using 11/16 drill as a pilot, and then bore it out to 18. hole in the other side of the piece didn't go all the way through, but it does now. So I'm going to take the first pass with a boring bar, and that's to create a clearance hole through the middle at 18mm. I think the 18mm is just a clearance hole. I don't think the dimension is critical, but I will still try and hit it just for the practice. Right, so let's see where we finished up. Somewhere near 18, hopefully. I guess that's pretty close to 18. Oh, I made the picture. Where's the camera? Got lucky there. I have to bore at 25mm for 32. Right, well, this is going to be the last cut with a 0.5mm depth of cut, and I'm shooting for 25. Okay, time to see how we went. Well, I think it's going to be somewhere near 25. And I was finding this a bit awkward, so it might not be exactly 25. Yeah, 24.994. Well, that's pretty close. I'm happy with that. Okay, next thing is to put a bore in here which is intended for a bearing. So I have to fit a 28mm bearing, so I've got to work out for myself what diameter of bore to shoot for. I calibrated this using the measuring piece that it came with, so I'm pretty confident. But it's really hot today, so things seem to be moving around a little bit. But anyway, as you can see, the bearing mic's at 27.996. So I decided for this bore to shoot for 27.99, or maybe 86, anything over. Well, anyway, I got 27.99, and the bearing is a satisfying hard press fit. I can put it in cockeyed, it's not going to help, is it? I made this little fixture up so I can knock the bearing out, so looks like I need to use it. Right. Yeah, so when I machined this test piece, I put a couple of slots in the back there. Let's try again. Get it a bit squarer this time. Something like that, maybe. Right, I think you could probably hear there, that's actually a pretty snug fit in there. I don't want it to be any looser anyway. If it was a bit tighter, I'd have to use a press, which wouldn't be all bad. But the So I think that was all a worthwhile exercise, and I've proven to myself that given the bearing measures 27.996, I'm going to shoot for 27.990 or maybe 27.988 at the smallest, and I think that's going to be a good fit. So it didn't take very long to knock this test piece up, but it's given me the confidence of what size bore to shoot for. So the bearing I want to put in here is a 28 OD, 28mm OD, and it's got to be 8mm deep. And from that exercise I've just done, I'll be aiming for 27.990 as the bore, and hopefully we get pretty close. So we'll start off with going in at 26, I think, I'm going to put the air conditioner back on because it's damn hot out here. 27.97. That might just be a little bit too tight. I've reset the DRO to acknowledge that the diameter is 27.97, and we'll take another pass at 27.98. That's what I'm going to do. That set up a bit of a chatter for some reason. I was shooting it for 27.990 plus nothing minus 0.005. Well, I think within the limits of my ability to read this thing, I'm going to call that okay. I'm sure I'll be able to press the bearing in there without any trouble. So, job done. I imagine we finished up somewhere near 51. 51002. Yeah, well, it's close enough for me. So apart from a bit of chamfering deburring, that's finished this end inside and out. So a new day, but still very hot. So the air conditioner's back on, I'm afraid. Now apologies if you can hear a low hum in the background. So I've got this thing turned around in the lathe, and my original idea had been to run it on one of these adjustable split arbors and mount it between centres. But when I set it up, the best run out, or the least run out I could get, was 0.08, and I wasn't really happy with that. Also there was another issue, as I think you'll be able to see up here, with running out of space to comfortably operate the top slide, because I've got to cut a 15-degree taper here. So I decided to put it in the chuck and see what sort of a run out I got there. And I think you'll be able to see we've got a run out of about 0.04, something like that. And that's 1.5 to 2 thou. I can tolerate that because obviously that's 1.5 to 2 thou over about 2.5 inches or something. So I think that'll be alright. In any case, I can't see any way to easily improve on that. So that's what we're going with. So I'm going to start by bringing this piece to length of 47.5, and then move on to taking this diameter down to 47.6 millimeters up to the face of the mounting flange, because that's the diameter where the 15-degree taper piece meets the face. I think I'll go for 47.61. Oh, it's cooled down. Oh no, it's still quite warm. Right, I've left about 0.5 millimetre on that flange to come off. 47.617, that's fine. I think that's going to shrink a bit when it cools down too. I don't know how much. It's one of the other reasons why I was happy to stay slightly oversized. Yeah, it's cooled down a bit already. 47.611. So I think I'll go and get a cup of coffee, let that cool down, and then come back for a final measurement. Right, so I've had my cup of coffee. It's cooled down to room temperature. I was originally shooting for 47.6. What do we get at room temperature? $47,599. Well, I'll be happy with that. So I think I'll start roughing this end down now. It goes down to 35 millimeters for 20 in. But I think I only take it into 19, because maybe even 18, because I want to maximise my chance of getting a curvy stress relief in the inflection point. I'm just doing a test cut or two with this button insert tool to see how well it cuts the aluminium. It looks like it does it pretty well. I think the exact location of that inflection point is not particularly critical. Well, let's try going in at 37. and then I don't know, wing it a bit. See what happens. I don't know. Well, that seemed to work all right, didn't it? A lovely change of direction. Yeah, that's good. All right. Yeah, so I'm not very happy about how I'm doing this. I managed to get a small groove back there, so I'll have one more go at trying to clean that up, I suppose, and see how we go. So that last cut would have taken me slightly undersized on the 35. Yeah, 34.87. Well, if that's the worst mistake I make on this job, I can't get too upset. 34.9. Yeah, well, a little bit undersized. Fortunately, that dimension doesn't match with anything else, so it doesn't matter. Just annoying. Alright, so now I've just got to clean this face here up. Right, well, that's got all the outside features on this done, and it's as good as I can get it, so I'll have to be happy with that. So time to look at boring the end here for this bearing. This bearing is 22 diameter, 22 OD. So checking the size after that final pass, the bearing mic'd at 21.996. So I was aiming I was aiming at 21.99, and I wouldn't mind if it was 29.98. Yeah, happy with that. So I might not have done spectacularly well on the outside there, but I'm pretty happy with the way the bearing fits turned out. Alright, well, that's that piece finished as far as the lathe turning is concerned. So it's over to the milling machine now for some the other features, a big hole through here and a hole pattern. So I'm turning my attention to the crankcase now, and I'm hoping to get it out of this block of aluminium that I had on hand. Now, I actually marked it out. There are two different ways I could mark it out. It's 63.5 square and somewhat longer. And the piece that I need to get is 54, 62, 63. So I first up I marked it out to get the 54 from the length. But that would have been really scrimping. I would have needed to get a 63 dimension out of a piece that was 63.5. And it sort of appealed to me a bit at first to do that, because I get really stingy with my material. I always want to use the smallest piece that I can get away with using. But when I looked more closely at this particular piece, it's been kicked around from pillar to post for many years, and there's some fairly hefty marks and scratches on it. So in the end I decided to remark it, and I'll take a 63 from the length and 54 from the other two dimensions. So that gives me quite a bit more latitude to find unmarked surfaces. Anyway, time to start cutting. This coolant is getting pretty scruffy, but I somehow don't think it's an issue for hacksaw, bandsaw. I'll just check, stop and see how straight we're cutting. Yeah, that's looking pretty good. There we go. Not a bad cut for a cheapo bandsaw. Those bands there, I got a bit impatient and started leaning on it a bit. Otherwise it would have been a pretty smooth cut, I reckon. Anyway, let's take it out and see how square the cut is. That's probably more important. Well, that's pretty good, not complaining about that. Yeah, well, that's pretty good. It's wandered off just a bit there. That's where I was leaning on it though, I think. Anyway, let's get into the milling machine. So we're going to start off with some light cuts to clean it up and get it square, and then I'll decide how I'm going to actually use the material. Interesting what a dull surface that cutter is leaving. It's quite smooth. Alright, let's do the other faces. Alright, so let's cut it to length and got rid of all the ugly bits. Got a nice clean cube. Not to size yet, so that's the next thing, is to check the dimensions and work out which way around I want to use it, and then start getting into this machining. So it turned out that I didn't in fact need to make the piece longer. I could get what I needed out of the two 63.5 dimensions anyway, so that left me with a need to shorten it from shorten my blank from 64 to 54 millimeters. So I had to mow off quite a bit of aluminium. Now I thought you might find it a bit amusing to see some of that happening. And yes, there is actually a workpiece under that mountain of chips. So I think you'll see that came out quite well. The cutters were doing a good job. In fact, that 3-flute cutter, you might argue, did overachieved. I didn't notice that the cutter was actually working its way out of the chuck, so I finished up cutting the 54 dimension a bit too short. I think we're about nearly half a millimetre short. So I don't know at this stage whether or not this is going to become scrap or I can salvage it. I'm pretty hopeful I'll be able to salvage it, so I'm going to press on. The thing is, I need to bore a hole in. This will be the front face. Need to bore a hole which will register this spigot, I guess. And then I'll drill a set of holes around the flange. So basically I can't finish this piece without that, because I want to use this piece as the fixture to hold this for the drilling. Yeah. So anyway, next move is hole through there and bore it out to that size. Right, so the drawing calls for that spigot to be 51, and as you see coming off the lathe I've got pretty close to that. So my target for this new hole is 51, and I don't know how much I'll have to open it up to get it needs to be a close slip fit basically. It's a locating register. So apologies for background noise, but it's raining, there's some machinery running beside me, so I'll do the best I can. Anyway, so the hole in the block here for the nose piece register is on the centre line vertically, but horizontally it's ½ millimetre below centre to create a bit more material at the top here for the cylinder to bolt onto, I expect. Anyway, I'm going to start off with a pilot 6mm drill, open it out with a 1-inch twist drill, and then attack it with a boring head. Alright, so I'm set up with an auto feed, and I've set the trip for when it comes out the bottom of the block. Fingers crossed. So after a bit of experimentation, I found that I did a lot better with depth of cut about 1 to 2 millimeters in that range. As the swarf that was coming out, it was much easier to manage. I wasn't getting lots of little bits and pieces that just jammed up down the bottom. And I found that I could just pull it out from underneath as it was being produced. So we're sitting on 41 millimeters diameter at the moment, and I've got to start getting my sizing sorted out. So to get myself dialed in, I'm aiming at 44 millimeters with this pass, and we'll see how that works out. Alright, well I think you could see that I was managing the swarf a bit more easily with that. Anyway, let's check the size of the hole we got. It looks like we're pretty close. 4403. Yeah, okay. And that wasn't trying to sneak up on it, that just took a big pass. And alright, well I want to get closer. I think I'm going to have the confidence to hit the mark that I want when I get there. Okay, so I've just taken what I hope will be the last pass with the boring head. Right. Remember we were shooting for 51, possibly a hair over 51, because this thing needs to be a slip fit, not 50.994. That might actually be a bit tight. Let's try the piece and see what happens. I don't really want it to be a tight fit. Close would be good. Alright, well I'm happy with that. I don't think I could have asked for a better fit. So, now I've got to get sorted to drill the bolt pattern around the flange. Well, that turned out rather well, very happy with that. So getting set up now to drill the hole pattern through this flange and into the crankcase block. So to explain the setup, this piece is a snug fit in there as you saw earlier, but to make sure it doesn't move when I'm drilling the hole, I've got a bolt going all the way through it, and you can perhaps just see down at the bottom there, that green thing is actually a scrap of steel bar with a tapped hole that matches the bolt. So that's using the bolt and the bar just to clamp these two pieces together. And to make sure I had the hole pattern laid out correctly, it's got to be 8 holes, but the hole pattern is rotated 22.5 degrees from one of the X or Y axis. So just to prove to myself that I had it correct, I mounted a felt tip pen in the chuck and went around marking the hole spots just to validate that I was going to get what I needed. So final check to make sure I've got the things centered correctly. And I can go all the way around, but you'll only see it in that quadrant. But I was quite happy with that, so we're on centre, good to go. Change of plan. This is held to that with M3 cap screws, which means a 2.5mm hole pattern's got to be drilled into here. My original idea had been to drill through with a long series drill, but when I thought about it, I realised that these holes need to be very close to the wall of the bore, and working with a long series skinny drill like that, I didn't have confidence that the hole position would stay exactly where I wanted it to be. So the new plan is to use a standard length 2.5mm drill with only 20mm sticking out, so that should give me pretty good control of where the hole goes, and put the hole pattern in there. Then I'll stick this on top and spot through with a long series M3 drill, and that should give me what I'm looking for. Fingers crossed. So with a bit of luck, there'll be 8 holes in the right place. Now I'm going to have to tap them, of course. Right, so I've started the tapping, and I'm just doing it with a manual tap by hand. The first hole I did up the back there, I used this tapping fluid to help. This is really treacly. It's very good for adhering to spinning things like if you're tapping under power. But I found that it was quite heavy going up here. So the next hole I did using what I've typically done for hand tapping, the Trefolex. I don't know that this is terribly suited for machine tapping, but I can tell you there was a very significant difference in the amount of effort required to turn the tap using the Trefolex. It was much easier. So this is what I'll be using for the rest of the job. So that's got all 8 holes tapped, and now it's something of an accuracy challenge, isn't it, to see whether or not I can drill the same pattern in this piece. So cutting a long story short, I didn't originally drill the hole deep enough. So I went back and touched it with the drill again, another 0.5 mm deeper, and the screw still wasn't happy. So I convinced myself I needed to run the tap through to clean the intersection of the 2 pieces of metal up. And that worked on the first hole. But later on I tried to do it again on another one, and it didn't feel nice at all. So I stopped and investigated and realised that I'd not understood correctly what was going on. Well, it's just as well I didn't try and do any more retapping, because I'd misdiagnosed the problem. As you can see, these holes do all line up perfectly. The reason I was having a problem here is that the tap is slightly over 3 mm, and it actually started cutting a thread in the what should have been the clearance hole. And then it continued that down into the underlying hole. So that's created an issue to worry about. But all of the others now, they're all fine. I just after I cleaned that hole out, the screws all line up perfectly. So the issue I've got left to resolve is what to do with this hole, which I basically started to cross thread. So I solved this problem by drilling out the top 4 mm of threads, which were the cross-threaded bit. The thread beneath that was fine, and the spec called for screws that were 10 mm long, but I originally drilled the holes and tapped deeper than they needed to be. So I've got a screw here which is 4 mm longer than the original, and that will reach to 4 mm down the hole to pick up the original threads. And everybody should be happy. Right, so let's try putting it, doing an assembly and see how it looks. I have to clean up the underside of these holes as well, and I'm not sure exactly how to do that yet because they are right next to the spigot. So I think I might have to do some very careful file operations or something. I'm just not sure yet how to do that because there's no room for a normal countersinking type solution. Anyway, we'll come back to that. So let's get this on, and if I use these long screws, now you can see that this is these holes are very accurately placed, because the holes that these 3 mm screws are in now are 0.05 over 3 mm, so there's really very little movement. But anyway, we can see that that's going to happily go down there. That's good. So now I can take all these long ones out and replace them with the short ones. Alright, so that's got that together. That's the first sub-assembly for this project. Quite happy with the way that turned out. Yes, that's the top. So now I can mount it in the vise and mill out the opening for the cam drive belt. Getting through this project without damaging the aluminium is going to be a major issue though. I've already got a little nick just there. Well, c'est la vie. I'll just do the best I can. Anyway, let's get it in the vise and mill this opening. Right, so I have to cut a rectangular opening here that's basically 23 mm that direction and 13 that way. And my plan, it has rounded corners, and the radius at the corner is 2.5 mm. So my plan is to punch some holes, one in each corner and one in the middle of each of the long sides, inboard of the finished size, using a 5 mm slot drill, and then also punch a couple of 12 mm holes through, and that will rough out the major size of the opening. And then I'll run around the opening either with this 5 mm end mill, or if maybe this longer one if it's needed to reach further down. So that's the plan. So we're going to start off with putting 6 5mm holes in hopefully the right place. I think now we'll switch over to putting a 12mm plunge there and there, and I should be left with mostly hole and not much to clean off around the outside. Well, seems to have worked all right there, so we'll switch over to the other side of the centre line. 5mm on the other side. Well, that's most of the hole. Still looks a bit hard to see exactly what I'm doing, but now I've just got to run around the edges with the 5mm cutter. Okay, so I've taken all that material out and run this 5mm cutter all the way around the outside, and I did it set 0.1 inboard of what it would be to generate the correct size. So as a result, this hole is 0.2 small that way and 0.2 small that way. But the reason I did that is that I didn't do a very good job with this taper, and I finished up with quite a piece here which is untapered. And as it happens, this hole is finished right on that transition point, which is rather convenient, aesthetically at least. So I'm going to leave the hole the way it is for the time being, and when I've got the belt in there and seen how the clearances work and all the rest of it, it may be the case that this hole is big enough, in which case I'll leave it alone. But if it isn't and I have to return to it, well, that's not a big deal to make this set up again and clean it out a bit more. In passing, I don't know whether it's just me, but when I look at this thing with that hole, I'm reminded of one of the moonshot rocket things, perhaps the one that actually orbited the moon. Perhaps I'm just dreaming. Anyway, so I'm calling this piece finished for now. Well, I'm rather pleased with my progress. I have my first sub-assembly, and I've done the hardest part of most projects for me. I've started. Anyway, I hope you enjoyed that, found it entertaining, and perhaps learned some things to do, and probably more likely some things not to do. Anyway, in the next episode I'll be looking at the cylinder and the cylinder liner, and I'll have to get off the fence about whether to scrap this part or use it. So, hope you can join me in part 2, and in any case, thanks for watching this video. Cheers.